Hello and welcome, everyone. My name is Finnegan Mwape. I'm the Vice President of Global Sales at Measurand. I'm joined by my colleague Matthew Miller. We're excited to be sponsors of this year's Minds and Mets conference, and hopefully we'll be able to share pertinent information regarding innovative equipment, technology, and services that we provide as a service. As you know, with a focus on tailings and management of those tailings, it's very challenging to keep up with the ongoing demands if you consider environmental concerns and just the increase in in the size of these tailings as your mining operations go on. So we hope to communicate how our innovative products are solving that challenge. When you focus a little bit about what's going on right now in the world as mining operations increase and as environmental concerns come to the forefront, the downstream management of tailings facilities has become a concern. And every time you start looking at the changing profile in tailings facilities, you start to realize that every time your profile length changes or height changes, you require new instruments that can keep up with that profile. And with this, it means that every time there's a lift in the change in profile, you potentially need new equipment. You potentially need to have manpower out there implementing your new parameters in your monitoring program. This is a very challenging uh, theme, not just from the procurement of these instruments, but the commitment of resources from your operations to then take care of these downstream demands of managing tailings facilities. Now, what we've seen when we develop products at Measurand is not just this highlighted concern with tailings, managing tailings facilities, but it's multiple sectors of concerns just like this where they need products that can pinpoint these pains and solve them. So when we develop our products at Measure, and the innovation is from the outside in. What do I mean by that? We look at what are the challenging ways in which these instruments are used in monitoring programs. So we design our products to be responsive to those challenges. If you take our flagship product, which is the Shape Array, we construct it in such a way that it arrives assembled and calibrated and ready to be deployed from the reel. It's fast and simple to install. In fact, it's about 75% faster than traditional instruments that are like in the installation process. And it's an open system that you can connect to data acquisition systems that give you pertinent information in the management of your infrastructure and other assets in near real time. And it's very amenable to automation, which further serves you uh, the, the time and allows you to then redeploy resources that would otherwise be committed into the implementation of these monitoring programs. So with that, uh, my colleague Matthew Miller is going to touch on how the Shape Array Extend, which is our newest innovation, fits into this client-centric development of products that are very responsive to these pain points uh, within a variety of sectors and specifically to the mining sector. Matthew?
Yeah, thanks, Finn. And thanks everyone for tuning in today. It's a pleasure to be virtually presenting here at Mind the Mets as our first year. And we'll give you a quick introduction to our newest innovation here at the SAB Extend. And please do not hesitate to reach out to Finn or myself should this short session not cover the topics that you're looking for. So here to jump right into the components of SAB Extend and how it differentiates from our original model SAB. But before jumping into the differences, I think it's best just to kind of lay down some terminology that I'll be using to differentiate between the new components. So starting from the bottom of the casing illustration is what we now call the base array. So you can think of the base array as your standard SAB, meaning that it's still composed of your half-meter segments in a customized length but that length is non-adjustable. So at the top of the base array is your first extender or your first connectable, allowing for the lift extensions to come in, and that is alleviating that top section to add more sensorized components in between the cable terminator as well and the base array. So looking at the middle section here, those lift extension segments, the operator here can implement these lift extensions to extend the monitoring profile of the SAV. And again, these are sensorized segments that can be customized in 0.5 meters for a minimum of 1 meter based on the construction intentions on site. And then lastly, at the top is the top assembly. So what's different here compared to our original SAV is that the spring box, for those who are familiar, used to be detachable. You could thread it on and off of the cable terminator at the top of the instrument, but now that cable terminator and the spring box are welded together so that it's a single component that is removable by that extendable connector. So here we have a close-up of the some product images of the different components I just mentioned. Again, the left, the base array, having the eye bolt at the bottom, your sensorized segments up to the first connector, your lift segments, which can be purchased after sale. They're not serialized to each SAV. These can be purchased, years after sale and swapped between each instruments as they serialize together in the field, and then that will continue your profile. And then, of course, again, the new top assembly. So I am short on time, but I do have a couple demos here, and I'll just quickly pull these up so you can get a feel. So for those that can see it here, I'll back up. This is the base array. So you have your eye bolts here. These is 2 sensorized segments, and then here is just the first connector, and we have a cap that's included, and this allows you to do that connection in the field with the your lift segments, but this will come assembled to the top assembly as your minimum installed base array. So similarly, you have your lift extension segment, again a connector on each end, and this is the 1 meter lift that can be assembled to the instrument in the field. And finally, the cable terminator. So I just have about 3 meters of communication cable here. It looks like an extension cord type material, your welded spring box, and then the connector here again at the bottom. So this would arrive assembled to your base with the eye bolt, and then you'd be able to manipulate this instrument in the field as you see fit. Now, to talk a little about the installation overview, as I mentioned, the SAV will arrive similarly to your original SAV models for those that have them on their sites, and this would be installed into your either new or existing casing. It can be PVC from 2 to 4 inches or grooved inclinometer casing. And then from there, you can either add them at the time of the install, your lift extensions, or afterwards. Say you have a lift program over subsequent years and you want to monitor that fill placement, you can easily just remove the casing and the top, quickly disconnect your components in the field, add those lift sensorized segments, repair it to the logger, and then continue your monitoring profile without having to rebaseline and remove the instrument entirely. And I should mention as well, we have extensive articles on our support website, support.measurand.com, that covers the hardware of the install, the lift extensions, as well as the software manipulation needed to complete your data management. Now, I got right into the extend components because we're here short on time, but just to bring everyone up to speed for those that aren't already familiar, the shape array is comprised of, again, the half-meter segments for vertical installations, and each segment is independent. So it contains a MEMS accelerometer, a microprocessor, and a temperature sensor so that you can determine the tilt of each segment, creating that 3D polyline in space. So the shape array gets its name because you're measuring changes of shape in the instrument. So looking at the quick 2D plot there, when you install your instrument, you can determine the absolute shape or the cumulative deviation of that borehole. And then to determine your displacement, your rate of movement, and your direction, you can just, what the math is in software is you're essentially just taking the new shapes and subtracting those against your baseline reading to give you those subsequent profiles and that change of, that rate of change of movement. And then just a little bit here, that's again, standard to our other SAV installs. The casing cap, extension tubes, and spring box. These are all unique hardware components to SAV and SAV Extend that allow the direct cyclical install into inclinometer casing. And with that too, similar to extension tubes that are non-sensorized at the top, we also have silent segments to further improve your program in terms of the economical implementation. Say you have existing casings on site that do not need certain elevations at the top or the bottom sensorized, then perhaps you could just go with the standard SAB with some sound segments and then position that instrument at the appropriate location as designated by the site engineers. Lastly, for some of the technical pieces here, so I mentioned cyclical quite a bit in this presentation. So cyclical is what we refer to as the shape of the instrument it forms in the casing. Because we don't need centralizers or additional casing or grout to install the instrument, it can go directly into new or existing inclinometer casing, and it's compressed in place to give you a 3D data set. So the cyclical, or the medial axis, we call it, is the line of best fit through that 3D data set that's provided by each segment. So you get your X and Y magnitude for your direction and magnitude of the tilt, and then your Z coordinate is calculated based on the length of the segment. So it's not giving you an axial force measurement, but that's how you determine your polyline, is using that trigonometry approach of the direction and magnitude over the length of the segment and then accumulating that throughout the profile of the borehole. Now that was pretty quick, of the essentials here, what I consider the, necessities to understand SAV and SAV Extend. But please do not hesitate to reach out to myself or our technical team for more info here. And then with that, I'd like to hand it back to Finn to talk a little bit about our experience in the sector, as well as some closing remarks.
Thank you, Matt. As with any innovative product that's fairly new on the market, one of the questions that you get asked is, what's the adoption around the world? What's the adoption in different sectors? What's the credibility of this product, and is it reliable? Can I use this in my operation? So we've basically, with a caveat here, used information from the oil sands sector, which is pretty close to the operations and tailings facilities management to mining, and used 10 years worth of data from there and about 300 plus instruments extending over 30,000 meters to use that information and really base our innovative product, which is the Shape Array Extend, on that experience. And as you can see here, the product is pretty much worldwide. The Shape Array is pretty much adopted worldwide. And it covers a myriad of applications, from earth embankment dams all the way to rockfield dams and asphalt core dams. So it's not just specific or limited to the mine sector, but it's widely adopted in the energy sector as well. So that should lend credibility to the product. And as Matthew said, we're excited to be first-time presenters and sponsors at Mines and Mets this year. Hopefully we'll be doing this in person next year, and hope to meet some of you in person. If you have any questions or we didn't cover a topic in this sharing of information that is something that you want to learn about, please get in touch with us through either the information on the screen now or through our sales or technical support portal. It's been a pleasure. and hope to see you soon. Thank you.
Thanks, everyone.